We're starting to talk about the Taylor. Taylor polynomials. So here the key thing is we have two Taylor polynomials. One is centered about x is equal to 0, and it has a name, the Maclaurine series. Maclaurine polynomial. And then the second one centered about x is equal to a. This carries the name Taylor polynomial. That is with the formula P n, where n is the highest derivative. So this is f of a plus f prime of a over 1 factorial and then x minus a plus f prime prime of a x minus a squared over 2 factorial plus f prime 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 of a x minus a power 3 over 3 factorial plus f4 a x minus a power 4 over 4 factorial plus plus f n x minus a n over n factorial. So this also has got, so this is the whole Taylor centered at a of the nth degree. Now, this a can be 0. So if a is 0, then you have the Maclaurine. Then the Maclaurine should appear in this form: f of 0 plus f prime of 0, x minus 0 is just x, plus f prime prime of 0, x squared over 2 factorial plus f prime prime of 0, x3 over 3 factorial. So it will keep going like that. Now this Taylor produces series. Those series, sometimes you predict them yourselves. So as you keep getting these number of derivatives and see what pattern you are getting, because the pattern will eventually be just a variable x, since you are evaluating the function that you have at some number and then remain with the variables x. So you can see how the variables x are remaining coefficients, and then you can create a relationship of the coefficients and the variables remaining to form a series. So what was supposed to follow down here is just maybe, okay, we do one example. Let's do maybe 2 examples and see what we get. Examples. One, find the Taylor Find the Taylor polynomial P3x for f of x is equal to, let's see this one, then x about x is equal to e. Okay, so P3 meaning we go up to power 3. And then, so what do we need for us to go up to power 3? We need, first thing, we need the first derivative. Or first we need f of e. F of e is ln e, which is 1. And then second, f prime of x. The derivative there is 1 over x. And then quickly we get f prime of e, which is 1 over e. And then the second derivative of x. So here to differentiate, this can be written as x to the power negative 1. So the derivative becomes negative 1, negative x to the power negative 2. If we evaluate f prime prime of e, then we'll get negative 1 over e, and then we square. So when we take negative down, it becomes positive. The third derivative is going to be negative negative, that is positive 2x to the power negative 3. So that when you do f1, 2, 3 of e, we substitute. This is 2 over e power 3. So we have all the needed things. Then now we write P3x is going to be, P3x is going to be, the first one is supposed to be FE. So FE is 1 plus FE plus the second one, 1 over E, that is F prime, multiplied by X minus E, plus, now we have a minus 1. So I'll put minus direct. So say minus 1 over E squared X minus E squared, and then plus the third one. After here we do, this was 1 factorial. So this one is 2 factorial, which is just 2. And then plus 2 over E3 X minus E to the power 3 over 3 factorial. And then we end there because just wanted up to the third. So this is 1 plus 1 over E X minus E minus 1 over 2E squared X minus E squared plus 2, that is 3 times 2. So we can just write 1 over E3. And then the remaining 3 we put it here. Then X minus E3 like that. So in some cases, it will be easy once you reach here. You can write the general formula. In some cases, it may be tricky for us to write the general formula there. So depending on what you are dealing with, it will be easy. Let's see another one. Let's see another one, how many we can need. 2. We say find the first 4 terms in the Taylor polynomial, or we call it the Maclaurine, so that we also deal with it in the Maclaurine polynomial of f of x is equal to sine x. Let's see how many derivatives we need. Find the first four. There should be non-zero terms. So one, the first one is for the Maclaurine. So it's, of course, once you see Maclaurine, you don't start looking for the x. You know x is equal to 0 for the Maclaurine. So about x is equal to 0. So you do f of 0, sine 0 is 0. So you know the first one is not giving us any term. Then we move, we differentiate it, we get cos x, and then do f prime of cos, f prime of 0, that is cos 0, giving us 1. The third, we differentiate again, so we get the second derivative. So what is f prime prime of x? That is negative sine of x. So we know f prime prime of 0 is 0 because that is sine. So we go to the third, we get negative cos, and then f prime 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 of 0, that is negative 1 now. So we have two terms. We will need 4, so we continue. The fourth, we'll get positive sine x. So you know the fourth will give us 0. And so the fourth I put I. Yeah, what I guess. Then the fifth. So it's now like you have restarted. That is cos x. So I'll get f5 0 1. That is the third term. So the 6 won't give us anything because that will be negative sine x. So it will give us 0. And then the 7th, that's where now we get negative cos, giving us negative 1. So now we have 1, 2, 3, 4. These are not the terms, these are the coefficients. So now we write the whole thing. So we have Pn. So since we know now the n, we can even put the actual n. So P7, showing that you understand what you're doing. So P7 is equal to, the first one is 0 plus, the second one is 1. So I'll have 1 for f prime multiplied by x minus 0, so just put x. And then the third one is 0. The fourth one is negative. So we'll have, this is 0 minus x squared. So you know this is 0 over 0 factorial, x over 1 factorial, 0 over 2 factorial. So this one will be over 3 factorial. And then plus 0 over 4 factorial plus x. So this was, this is supposed to be x3. Well, this was x squared here. Then x4 here, x5 here, x5 over 5 factorial and then to plus 0x6. So of course over 6 factorial minus x7 over 7 factorial. So this means that the term that we want, the first 4 term, will be x minus x3 over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial. Keeps going. So this means that if now they ask you to write this as a series, at least you have an idea. You've seen that all the powers of x that you're getting here are odd powers. And they look like they're not just the best is to say they're odd powers because we just be skipping even ones. So if you had to write this as one thing, at least you know for the power you have. Where you have to be careful now is for the negative, because is when it comes. It just doesn't come. So though we have the same type of powers, but the negative disappears, it appears, disappears, it appears, like that. And there you get to be a bit careful on the negatives. So do you have a question on the composition of this?
Excuse me, sir.
Yes, sir.
May you flip back to the Taylor where you started from? The other one. Okay. So somebody was saying Taylor is the opposite of Maclaurine or something like that. So I don't know how they are.
No, the only difference between the two is that they're almost the same things, except that Taylor is a general one. So
Okay.
Taylor is a general one. You can operate, because the same thing that you're calling the Maclaurine polynomial is a Taylor polynomial, except is a Taylor when x is equal to 0. So when you're subtracting this a, so a is equal to 0.
Okay.
So a is equal to 0. That's the only thing there. Then the other one, a is equal to a number. Like you can have 4, you can have 2, you can have e, you can have anything.
Okay.
Yes. So now this x that I said.
Sir?
Hello?
Yes, sir. Come again.
So I was saying this x that you're saying is 0, we mean the value of a here.
Okay.
Yes.
So I was thinking that probably if we go with the actual class, what they are doing, because they will be having a test just after the break.
Just after the break?
Just after the break will be test. So we need to see what they are doing so that we solidify. The last time I attended Dr. Banda's class, things are very clear because of the setup and the cupboard. So it's not very clear.
Okay.
Yes, when he's teaching, it's not very clear because of the big class, and sometimes you don't sit too close to him, then you don't even get much of what he's saying.
Okay, so like today I was looking at this is lecture 7. The lecture notes.
Okay.
Yes.
he was dealing with the integration by part.
So I don't know if let me check, because I also have lecture 8. I don't know what is on lecture 8. I haven't opened it. Let me check.
Integration by parts is in the tutorial sheet 2, not so.
Or integration by
Parts. That's what he was doing last week. I mean, early this week, should be on Monday or Tuesday.
okay.
On Monday, actually.
Implicit. So that should be maybe in lecture 9 or lecture 10.
Oh, okay.
So we're on
Then
lecture
we
7.
are on track then.
Yes.
Okay.
Okay, so now the down part of lecture 7,
Mhm.
after we've done this example, is the mini-vary theorem
Mhm.
that we talked about.
Okay.
Unless there's someone who has a question on the mini-vary theorem.
I remember it very well.
So we have the mini-vary theorem down here and the Ross theorem, which we did. I think we talked about this twice. So unless there's
And the recording,
yeah,
have
just
you posted?
yes.
Okay. And then we'll have to go through them again.
Yeah, let's check.
Okay.
So
The other thing, so that I'll request is maybe you try to give us some hints of what we should be looking for when approaching a question.
okay.
Sometimes as the students, we beat about the bush and at the end of the day, not even get reasonable marks. But with your experience, obviously, you are able to say, when you see such a question, ask in which way you are. Issue.
Okay. Okay, so since we still have some time here, let's just roughly talk about it. There's a nice, I think, example here. So show that. So we just go straight to the example because we talked about the statement already. Example. Show that the equation x3 plus 3x plus 1 has exact one linear solution. So when you ask such a question, show that the equation of this has exactly one real solution. Well, if you attempt to solve for the solution, you can get it. But in most cases, when you're going for a test, like the coverage that you have covered. So okay, I think this test is centered on derivatives. So in the derivatives, I'll find mini-vary theorem, I find this. So you know that here they are not asking, because in this course, you're not doing polynomials. So they can't ask you to solve this as a polynomial, where you have to solve for the solution and check that what I'm getting is only one solution. Because you may even fail to solve for that solution here if you start solving for the actual solution. So you know that here I need to use the theorems that are around the coverage. So how do I use the theorem? So you check, like in the mini-vary theorem, in this case, we know it's about the mini-vary theorem. So we check the statement of the mini-vary theorem. Is it satisfied? To check if it is satisfied, we can make this, say this is f of x, which is x3 plus 3x plus 1. What does the mean value theorem want? It has to be differentiable. So you try to differentiate. Can I get the derivative here? F prime of x is 3x squared plus 3. It is differentiable. So you know, okay, it's differentiable. That's okay. What else? Since it's differentiable everywhere, so it means that NSI don't need n boundary around. And then the mean value theorem carries the Ross theorem. The Ross theorem is specific now. It talks about the zero itself. So you see, okay, if it talks about the zero itself under the mean value theorem, then I'll say, okay, I have two things. Suppose there's some number C that is giving this thing 0. So now we have gone to a specified, because knowing if we have two or more solutions here, we must check if we are bounding 0 in between, or we are getting the interval to be positive. So if I have f prime, the simplest theorem to use here is the Ross theorem. So I say, okay, let's see. F prime of C is 0, and this is our f prime here. So say, okay, so f prime of C is equal to 3c squared plus 3 is equal to 0. And check, is it possible that we can have such a thing? If we check, you realize that 3c squared plus 3 can actually never be equal to 0. Because if we force it to be 0, then we'll have this thing. If you have this thing, then you are saying c squared is equal to -1. Now, these are real numbers. So you know this is not possible. Okay, so if this is not possible, then it means that because the mean and the Ross theorem says for every two numbers, A and B, if F is differentiable and continuous on that interval, then there will be a C in between. So now we know that, oh, since there is no C, then it means we cannot find such two numbers where this is differentiable and continuous. So because I can't find the actual values, then what does it mean? So it means that we only have exactly one solution that will neutralize this into 0. So if we get from the statement, so we are saying, okay, since the first derivative is never 0, if f has as many as two zeros, by Ross theorem, f prime would have a 0 between them. So if we are in the Ross theorem, we know that f prime of A should be equal to f prime of B, and they are all equal to 0. When this happens, then you are saying there will be a C such that f prime of C is equal to 0. Now, in fact, these are just direct ones. They don't have to be differentiated. These are direct ones. So it's just f of A is equal to f of B is equal to 0. Implies that C, if this happens, where you get f of A, which is equal to f of B, which is equal to 0, then there is it's a must that there is a C in between. That makes it 0. Now, because we don't have those bounds there, and then which other way can you use to test? You just pick a positive and a negative number and see what happens. So if we pick, suppose we pick f of negative, let's pick -2. So f of -2 will be -2 to the power 3 plus 3 -2 plus 1. This will be -8 minus 6 plus 1, which is -14, which is -13. Then you also pick the +2. So you have 2, 3 plus 3 by 2 plus 1. This is 8 plus 6 plus 1, which is 15. So what does this mean? If you have a graph, when you use -2, you are getting the number -13. So it's somewhere down here, -13. You pick a point here. Then when you use 2, you get +15. So +15, meaning you're up there. So meaning that the curve, this is x3, will cross the x-axis. So the curve will cross the x-axis. So if it is crossing the x-axis, and we don't have this value now for f prime, where that can give us 0, then what does it mean? So it means that we only have one solution, because it automatically cross. So because it has crossed, we cannot find these A and B, two of them. That will give us zeros for us to obtain the derivative being level to 0 with a gradient equal to 0. So it means that we only have one solution in this case. So the key to answering this question is having understood the mean value theorem and its a Baby theorem, which is the Rose theorem. So if I understand the two statements and I find such a question and I know I cannot easily solve this to find how many solutions I'm obtaining. So it means I'll rush to mean value theorem. Now, because mean is too general, then I'll go to the Baby theorem, which talks about the zeros. Because the solution of this case should automatically be a 0. So because I can't get zeros from the f prime, then I know, okay, it's just about trying to get some numbers. I pick on the right and on the left of the 0, and then see the signs. If the signs differ, then it means I don't have so many solutions. I only have one, as it cuts. So you just make sure that you look at the statements again, and then when you get back to this, you appreciate the statements. So I think I'll be able to get the other lectures so that tomorrow we'll look at lecture 8 and lecture 9. Because lecture 8, there's nothing much, it's just about derivatives. So you can finish it in the first 40 minutes. In the second 40 minutes, we do lecture 9. And then, so if you can move fast to finish those notes, then we'll go to the tutorial sheet and then brush it off, and then you'll be ready for the test. So that we end here for now and carry on tomorrow.
Sir, what about Monday's recording?
Monday's recording, okay, let me check the recording that I have uploaded.
Okay, thank you, sir.
Okay.